So here, now we're going to talk about inverse functions. And the first topic before we actually get into inverse functions is understanding what what it means to be one-to-one. Okay? So in relations you have functions, but then within the group of functions you've got different types of functions, and one of the important groups that we're going to talk about is whether a function is one-to-one or not. Okay? So the definition of having of a one-to-one function or having one-to-oneness is, so for example, if we're talking about one-to-one functions, a function f is a one-to-one function if for a and b in the domain of f, right? So in other words, we're taking two separate x values, right, in the domain, two values in the domain of f, then that function is one-to-one if a equals b leads to f of a is not equal to f of b. So if we take two values of the domain, right, that are not equal to each other, and we put them in the function, evaluate the function at each of them, if it's one-to-one, then if they're not the same, if a is not equal to b, then f of a is not going to be equal to f of b, by definition. Okay? So if this is true, then they're one-to-one. So this is the definition. So if we have a one-to-one function, then this must be true. Okay? If a is not equal to b, then f of a is not equal to f of b. Okay? Also, equivalently, we can look at what we call the contrapositive, and the contrapositive says this. We could also look at it this way. If f of a is equal to f of b, then a must equal b. Okay? And so in this case here, when we get into problems where we want to prove or show that a function is a one-to-one function, that we will use this one. Okay? We'll set these two equal to each other, right? We'll just pick two values, a and b, right? We'll put a and b in there, and then what we'll do is we'll show that it automatically gives us a is equal to b. Okay? So, but that's the definition, and that's it.